Today we'll discuss about various scheduling algorithms. So these are all the scheduling algorithms: first come first serve, shortest job first, priority scheduling, round robin scheduling, multi-level queue scheduling, multi-level feedback queue scheduling. Under shortest job first, the process can arrive at same time or at different time, and preemptive version of the shortest job first with the different arrival time, we name that as shortest remaining time first. So priority scheduling, it can be of two types: preemptive as well as non-preemptive. First come first serve. So the order in which the process arrives into the system, they will be serviced. For example, we take a three process which arrives in order P1, P2, P3. So there are three processes arriving at different burst times. P1 is arriving at burst time is 24, P2 burst time is 3, and P3 burst time is 3. All the processors are arriving at same time, and the order is P1, P2, P3. So in this, we need to draw the Gantt chart, which represents the execution chart of the process, and then we need to calculate the average waiting time and average completion time. So here you can see the three process: P1 burst time is 24, P2 burst time is 3, and P3 burst time is 3. And the waiting time of the P1, we are drawing the Gantt chart. The P1 is starting its execution at time 0 and it is completing at 24. And then followed by the second process, P2 starts its execution and it completes by 27. 24 plus 3. 3 is the burst time of the process P2. And finally, the process P3 starts its execution from 27 and then its burst time is 3 and then it completes by 30. So the waiting time of P1 is 0 and waiting time of P2 is 24 and P3 is 27. And we say the completion time, the time of submission and then time of completion. So time of submission of P1 is at 0 and it completes at 24, so completion time is 24. And the time of submission of P2 is at 0 and then it completes by 27. So the completion time is 27. And same way for the process P3, the completion time is 30. When we calculate the average waiting time, so we need to find the average of all the waiting times of all the process P1, P2, P3. So 0 plus 24 plus 27 average to 3, we get the result as 17. And same way average turnaround time is 24 plus 27 plus 30, which is the completion time of all process P1, P2, P3. Average to 3, so 27. Suppose if the order is being changed, suppose if you are changing the order by P2, P3, P1, so what happens? So if you change the order, so the P2 gets executed first, P3 followed by P1, and we know the same burst time of P2, P3 is 3 and then P1 is 24. So we are redrawing the Gantt chart like this, and then when we find the waiting time of each process, then for P2 it is 0, for P3 it is 3 and then for P1 it is 6. When we find the average waiting time of all these three processes, which comes to 0 plus 3 plus 6, average to 3, which is 3. So which is very far less compared to the FCFS when the order of the processes P1, P2, P3. So there we got 17. And average turnaround time same way. So 3 plus 6 plus 30 by 13 to 13. Average 3, which comes to 13. So which is compared to 27, which is very far less. And the advantages of first come first serve. So advantages is it is easy to implement, and shortest job for disadvantages, shortest jobs will get stuck between the longest one, and because there is no preemption, all are executing under like non-preemptive category. So in non-preemption, if the process executes for a long time, the process in the back of the queue have to wait for the long time before they get a chance to get executed. The next video we'll see the shortest job first scheduling. Thank you.